Dear friends, this is Altera DE2 FPGA board. In this board, there are some switches SW0 to SW17, total 18 switches. These switches are normally used for giving the logical input to any sequential or combinational circuit. And there are some LEDs, LED R0 to LED R17, total 18 LEDs. These LEDs are normally used for watching the logical output of any logical circuit. In this project, we use only SW0 and SW1 for giving the logical input to AND gate, and we use LED R0 for watching the logical output of AND gate. Create a new folder and_gate. This is our project directory. Run quarters 2. Create a new project. File, new project. Next, define the project directory and get. Okay. Here write the project name and get. Next, we have no previous file, so we have no task in this section. Just click on next. Select the device family Cyclone 2. Our device family is Cyclone 2 and our chipset name is EP2C35F F67 EP2C35F67266. This is our chipset name. Click on next and finish. New project is created. In this new project, we have to create a Verilog file. New Verilog HDL file. Select Verilog HDL file and click on next. This is Verilog HDL file. In this Verilog HDL file, we have to write the necessary Verilog codes for implementing the logical AND gate. Every Verilog code is start with module keyword module and end with end module keyword. After module keyword, we have to write the module name and get and get. Our module name is AND gate, and after module name we have to declare all the variables used in this module: A, B and Y. We declared 3 variables A, B and Y. After that, put a semicolon. After this, we have to define which variables are input and which variables are output. Input A, B. That means A and B variables are input. Output Y. Y variable is output. After this, we assign the output variable Y as the logical AND operation between A and B variables, A and B. Here the ampersand sign is a logical operator. The ampersand sign performs the logical AND operation between A and B variables. and equal sign is a assignment operator that store the result of logical AND operation into y variable. Our code is complete. Now save the Verilog file. Our Verilog file name is and_get. Keep in mind the Verilog file name, module name must be same. Here .v means this is a Verilog file. Save Verilog file. After saving the Verilog file, we have to compile this code. This is compilation button. Click on compilation button. Compilation is started. Full compilation was successful. 13 warnings. After compilation, we have to assign the pin assignment for input and output variables. Now we have to assign pins for input and output. This is pin planner button. Click on pin planner button. Here we can find two variables A and B as input and one variable Y for output. In the location tab, we have to write the pin number of respected input and output. Where we can find the pin number? We can find the pin number from the user manual of DE2 FPGA board. This is user manual of DE2 FPGA board. In this file, we can find the pin number of SW0 and SW1. SW0 is used for input B and SW1 is used for input A. Just copy the pin number of SW0 and paste it to the location of variable B, and pin number of SW1 pin underscore N26, copy and paste it to variable input variable A, and the output Y will be shown through a LED R0. The pin number of LED R0 pin underscore A23, copy and paste it to the location of variable Y. Our pin assignment is completed. After completing pin assignment, we have to compile the program again. After completing compilation, we have to write the program to FPGA board. For this task, we have to go to programmer. This is programmer button. Just click on programmer. This is programmer window. In programmer window, click on hardware setup button. Here we can find the USB blaster. That means our FPGA board is connected properly to computer. Just double click on USB blaster and close. This is and_get.sof file. After completing successful compilation of Verilog code, a .sa file is created. The .sa file is a file that contains the binary information which will be written to FPGA chip. Just click on .sa file and click on start button, and the program in the .sa file will be written to FPGA board. Our FPGA board is connected to PC. The LED is blinking, that means the FPGA board is ready to accept any program from PC. When we click on the start button of PC, the program will be sent to FPGA board and light blinking will be stopped. Click on start. The light blinking stopped. Now we check input and output. We use two switches, SW0 and SW1 for input and LED0 for output. Here is the truth table of AND gate. When both input are 0, output 0, and when both input are 1, only then output will be 1. When SW0 and SW1 all of them are 0, output is 0. 0 1 0 1 0 0, and when both input are 1, then output is 1. That means AND gate is properly created in FPGA.